us today and take it away.
Alex, you're muted.
Yep.
Yes, thank you. Okay, so let me start over. So first of all, I want to say thank you very much for giving me the honor to be participating on this call and being able to demonstrate what Gencell is doing in this space. But as we are transitioning to a renewable energy environment, there's a lot of complexities and technologies that are out there that are designed to kind of solve some of these issues. And Gencell has really kind of taken a front seat on really trying to figure out how to best address some of the main challenges in the industry today. And hopefully that will be captured as we go through this presentation. So getting started a little bit about the company, that our vision is based on 100% green power. And our slogan is basically green power for humanity, because everything that we do, everything from the roadmap, everything from the inception of the company has all been based on making sure that A, power never becomes the limiting factor, but then two, that we're doing it in a clean, sustainable way. So you'll see a lot of the technologies and a lot of the things that we're developing are specifically designed to address that specific mission. Part of that is, if you look at Gencell as a company, is that we're 160 employees strong. We have well over 18 PhD level scientists, and that's really because we are in the business of solving problems. So we have everything from material science, engineering, from electrical, mechanical, civil, you name it, we have it. But again, it's all in premise is that a lot of these technologies do not exist today. So Gencell, being the innovative company that it is, we are really in the business of solving these specific problems, specifically in the energy sector. And I'll get a little bit more into that in just a few minutes. So obviously we have a lot of patents and trade secrets. We are on the Israeli Stock Exchange. We're operating in 23 different countries. And again, the main focus for us is to develop these innovative technologies when it comes to energy. Now, if you look at our overall evolution of our technology, particularly the roadmap in terms of how this technology is evolving, is that when you look at the first building component, because we're building blocks, is hydrogen to power. So we built a technology based on NASA technology that was around since the 1960s for space missions, but those technologies were very good for space programs out in space, but they were not very well suited for Earth missions, right? Not to mention that the cost factor, nobody has NASA budgets except NASA. So we had to figure out a way not only to bring that space technology back to Earth, but also make it economical. So we built a technology based on fuel cell technology, based on the alkaline version of the fuel cell, which is by far in the industry the most robust, most reliable technology. Because if you think about space programs of why NASA would bring a technology in play, is you got to have, at least in this case, two primary attributes. One of them has to be extremely simple in design, and the second one has to be extremely reliable in design. Okay, you have to have those two factors to really be applicable for NASA program technologies. So in everything that we do, we are typically operating in mission critical environments, because in the worlds that we play in, we cannot have power becoming the limiting factor, because both operationally and financially could be devastating both to the organization or to whatever it is that we're providing backup power to. So you'll get a little bit better sense of that in just a few minutes, but that was the first building block that we generated. We are in phase 2 now, and one of the biggest challenges that are in the industry when you're dealing with renewable energy as well as hydrogen is, how do you generate the hydrogen in a cost-effective manner, and how do you store it and dispense it, or transport it for that matter, in a cost-effective manner. So today, typically you have gaseous hydrogen and you have liquid hydrogen. They both have a certain amount of complexities because of the nature of the state of how they're managed. So we took a step back and we decided to create a third option, which in this case is using ammonia to power, which is NH3, which if you look at the chemical composition, is based on 3 molecules of hydrogen to 1 molecule of nitrogen. These molecules, once we split them apart, they're just 2 different elements. So we created the technology where we can very efficiently, in a closed loop environment, crack the ammonia molecule between hydrogen and nitrogen to make it to their individual elements. And now we can harvest out that hydrogen, put it into the fuel cell, and from that point forward, it's like me buying straight hydrogen from any other kind of source. But the beauty about this type of technology is that you have a high concentration of hydrogen that is necessary, and it gives you the simplicity of being able to store it in atmospheric temperatures, as well as very low pressures, not to mention that it's the second most produced chemical in the world. So a lot of industries have it, from agricultural, every farming in the US as well as around the world are using anhydrous ammonia as a fertilizer, but also as a refrigerant, and many other industries use it. So that means that all the infrastructure, the tanks, the equipment, the know-how, everything is very common and very inexpensive, which is the ideal hydrogen carrier for being able to get low-cost hydrogen. And just to put it in perspective, if you look at 1 gallon of ammonia compared to a gallon of diesel, you're looking at about a 3 to 4 factor. Okay, so 1 gallon of ammonia is approximately about $1.80, $1.90 a gallon, where depending on where you are in the country, a gallon of diesel will be anywhere from $3 to $6 a gallon. Okay, so not only are we highly more cost effective, but at the same time, it gives you all the great attributes of using hydrogen as a renewable energy resource to put it into a fuel cell. That fuel cell has no emissions, no combustion, no noise, no vibrations. So literally you can consider this as a computer that generates power. Now that's phase 2, and that'll be released this year, coming 2024. Now phase 3, and one of the ones that I'm actually most excited about, is what we consider water to power. In this case, think of a world where you're able to use water and a little bit of renewable energy to where you can generate green ammonia, but not in a $5 billion refinery somewhere at point A, and then you still have to transport it logistically all the way to point B. What we're able to do, and we've already successfully done it, and we actually just did a press release here earlier this week, is that we are now going to have the ability to self-generate your own fuel at the point of consumption. This is really it's a complete change in how business is done today when it comes to energy. And what this will be able to do is to be able to generate your own 100% green energy, create it in the form of ammonia, where you can store it in very inexpensive vessels for future consumption as you convert it back to electrical energy on demand wherever you need it. So that whole supply chain effort is typically, driving the cost of energy. All that disappears overnight. So now you're going to have a low-cost energy source that you'll be able to generate for pennies on the dollar at the point of consumption. So again, this is going to revolutionize the entire industry when it comes to energy. So this is part of the roadmap. This part of the roadmap, we're looking about 5 or 6 years out before we're commercially ready to release the water to power. But phase 2, being ammonia to power, that'll be released in 2024. Now, when you look at the types of applications that we're in, if you remember what I mentioned earlier, that we are in mission critical environments, is we're working at the utility level by providing emergency backup power to some of the most critical elements within their distribution and transmission sectors, right? Like at the substations and other elements. If you think about telecommunications, if you're thinking about fiber optic networks, your cell phone, your base stations, where all that communication, transactions, and monetary things happen, those are mission critical as well. We are backing up some of the largest companies in the world that are dealing in that space. Now we're also getting into the EV charging spaces, because that also has a mission critical component. If you think about a municipality that has police cars, and then you want to electrify those police cars, and that's fine, but what happens if the power becomes compromised because somebody hit a transformer and knocks power out for a temporary time frame? That means that you're not able to charge. So now we have to figure out, how do we solve that type of situation? Okay, so we are always working in these environments, and all our technology is really designed to address those specific applications within each one of those industries. Now, when it comes to microgrids, microgrids are very important in today's environment, because we need to start looking at distributed energy resources And resiliency is one of those most important assets, right? Because right now, the vast majority of our electricity is coming from power lines, which, they're very susceptible to weather events, people, hitting transformers, knocking those things out, telephone poles, whatever. And you really need to start looking at other options, not only for transmission, but also how to do it at the local community. So resiliency is one of those things that really need to be at the top of the mind to make sure that you're addressing each one of those elements. The second thing is also supporting the integration of renewable energy, right? So we're not just generating at one location, but you also want to start incorporating solar, wind, nuclear, hydroelectric, whatever it may be, and start putting that into the mix. Then you start looking at the security and the stability of the power grid, which is the critical part of the infrastructure, that as we start to electrify more and more of these elements, and we're not just talking about transportation, anything that typically is not electric today, everybody wants to electrify that, which means an enormous amount of demand obviously it's coming to fruition, which puts an enormous strain on the grid. And this is just it is what it is, and it's something that really you need to start looking at other options, or at least enhancements on adding additional power resources to support this additional demand. Now, when you start thinking about the microgrids and you're thinking solar, battery, fuel cells to kind of smooth out the peak demand charges, that's the other thing as well, right? Because as you create that initial demand, and we always talk about the duck curve, is that you also need to start thinking through is like, what is going to be that peak demand that the utilities are going to have, and how are you going to straighten that out to some degree? And these types of distributed energy resources can play a significant role in that process, particularly when you start now dealing with DC fast charging that takes an enormous amount of energy. So if you start thinking about, like class heavy duty vehicles, you're talking about the buses, the semi trucks. Now you're talking about cargo equipment and all these other elements that require an enormous amount of energy in a very short period of time. It just really creates a huge demand and an instability of the network. The next thing also is when you're thinking about how do I get the 483 phase to a location that I need it in, because in most locations for average applications, you're not going to have three-phase power. So now you're also putting a lot of strain on the utilities to start performing, to start bringing in that additional capacity to a very specific site. So by the time you do the permitting, the construction, the asset acquisition of transformers and all these other elements, it takes a lot of time to start doing that, which time is money, because in this case, now you're talking about that there's a short period of window of when you can start putting these strategies in place. And also a lot of people and companies and municipalities have also committed to certain deployments of going 100% green or as part of their fleet. And you're never going to be able to make those deadlines if you're not able to get the necessary power to the location that you need it in. So all of these types of elements creates a bottleneck in the industry that needs to be addressed. And we think us as Gencell, we have come up with certain technologies and ways of doing things that will help us expedite some of these challenges. In a short-term diagram, I'm a big believer that seeing is believing, and I'm a visual kind of guy, so I kind of wanted to put this in place. And basically, the way the system works is that the way our technology works today is that we have multiple energy inputs for energy resiliency and basically redundancy. So not only are we able to accept energy coming in from the grid in a bidirectional way, meaning that we can accept energy into our system, but we can also take energy out of a system and then put it back into the grid as well. Likewise, if you happen to have a solar element to it, we can receive energy coming from the solar. And then obviously we would have our fuel cell, which is our on-site generation system, which gives us the ability to start generating power on demand at the site, regardless of what the grid status is. So this kind of gives you that multi-purpose, multiple redundant energy inputs to make sure that you're not solely relying only on one energy resource. At the same time, is that we need to be able to connect to other systems like the SCADA system. You know, the utilities use their own systems that they're connecting to. They want to make sure that all their systems are operating correctly. We can connect to that and give them an enormous amount of information that would be extremely useful for their use. But at the same time, it's also for them to understand what is the operational intelligence that are necessary to maintain the whole process working in unison. At the same time, we also have a software package that works with distributed energy management systems so that we are able to manage and orchestrate exactly what is happening between each one of the power sources, whether it's grid, solar, or fuel cell, and also utilize the information about what is the most cost-effective energy source dynamically, so that we can make sure that we're putting in the lowest cost energy first before we start considering other options. So this will give us the ability to also manage and control not only the stability of the network, but also be able to use the lowest cost energy. Now, when you look at these microgrid capabilities and the benefits, is that when you start thinking about business continuity, as an example at the resource center that we just spoke about, is that this really kind of gives you the ability to harness all of the elements that are necessary to have a very dynamic, very useful resource center for that community, that you're leveraging all your resources. That includes the solar that's part of the program. You're looking at the fuel cell that hopefully will be part of that program, the electrical energy that's coming out of that program, and have the ability for that resource center provide the services necessary to that community, everything from the banking to the grocery store, the EV charging. So that's kind of like the epicenter of that community. So it is vital to make sure that that facility is operationally ready, no matter what the condition of the grid is, or no matter what the weather brings or doesn't bring. You have to have that resiliency. Part of that solution is that we are able to bring in three-phase power even on a short-term basis, because we know long-term SMUD is going to be bringing in three-phase power. However, with the Gencell technology as part of the overall system that we have already designed, is that we can also address that requirement immediately by having the ability for us to bring in the three-phase power by stepping up your existing infrastructure that you already have, and step up your 12208 and take it up to 480 volts, and then backfill in the energy gap to fulfill the requirements of the charging stations. The second thing too is that you can utilize this system as a distributed energy resource, which would be also an advantageous element for SMUD. When you start thinking about is that the land is already acquired, it's already there. You have a distributed energy resource with a high capacity battery of 372 kilowatt hours. You also have on-site generation for if there's any kind of elements where the grid happens to go offline, you can still leverage this unit. And then if necessary, you can even send the energy back to the grid should you want to decommission one of those Pico plants that maybe not get a lot of use, and maybe this is a much more cost-effective solution. So there's a lot of different elements that you can utilize these types of technologies to make sure that you're able to provide the EV charging and the infrastructure necessary to support those types of elements. It gives you the ability to support any kind of distributed energy resource, and also for the community, gives you the ability to maintain business continuity of that resource center. Now, converting one of these charging hubs is that it gives us the ability to, as I mentioned earlier, connect the solar to it. It gives you the ability to also look at peak demand charges so that you're stabilizing the overall energy cost of that facility. I know in speaking with some of the people there at the AQMD, is that the energy cost is a big factor in the long-term play on how we're going to support these communities when it comes to EV charging and some of the high energy demands. So this also helps you maintain those critical assets in a cost-effective manner by even keeping the process and as your existing infrastructure as a single-phase power, as opposed to maybe a three-phase power. Let's see. The other thing too is let's see. So that's pretty much it for the most part on those things. I think I already covered some of these elements, and I know we're running short on time, so I want to help expedite some of this. So if you look at that resource center, the CRP at the Luis Perez location, is that we took a snapshot of this as a use case, and we said, okay, what can we do with this location? So one of the things that we can add is add the EV charging stations. These are level 3 chargers, not level 2. So that way it gives the ability for people that have the EV cars coming off the highway or they're at the store, they can get in and get out, and you're not going to have a huge parking lot of people just waiting around the parking lot or even out in the street. This gives you the ability to get in and out very quickly. The second thing is that there's more than enough space to put in a 20-foot container that we can basically put on the property and try to containerize everything that would be necessary to upgrade the electrical infrastructure of this facility to not only give them the resilience that we talked about, but also the necessary electrical upgrades that it will need in order to support these level 3 chargers in an expeditious manner. Then we can also add the solar panels. This is, by the way, not to scale or not saying that this is the way the configuration where it needs to be. It's just a rendering. But the idea is to demonstrate is that there's a lot that can be done with a facility of this size and scale and provide a great resource for this community. This is just a couple other examples here. And again, I'm not saying that this is the way it necessarily needs to be put in place, but again, these were just renderings of a conceptual process. Now, the third thing that I would say is when you're dealing with the fact that you are going to be incorporating renewable energy resources like solar, wind, fuel cell, grid, software, all of these elements is a terrific opportunity to also partner with the local communities in order to make sure that the technical schools and the engineering university schools are educating the next generation of leaders on how all of these technology not only work individually, but how do they work collectively, right? And having a system like this operating at the local community where they can reference it, they can see it, they can experience it, it's a great training tool for them to be able to see that, not only is this the cutting edge technology, but they're among the first in the communities that are going to be receiving this type of technology for their benefit for upward mobility. So I think this is a great opportunity for us to collaborate together as a way to really develop the next generation of leaders on how these technologies can really make a significant way, and at the same time be able to provide the education and the awareness of how these communities and how these technologies are playing a significant part in their overall welfare. So with that, thank you very much for your attention. I want to make sure I have enough time for the next presenter. But again, it's an honor, and thank you very much again for giving me the opportunity to demonstrate and showcase this type of technology.
Great presentation, Alex. I can't thank you enough. So we've got, thank you for leaving time for some questions and answers. Eric, I'm not sure if your hand is still up from before or if that's a new hand raise.
Nope, that's a new hand.